In this video, we're asked to see whether a precipitate will form after mixing a solution of lead-2 nitrate together with a solution of potassium iodide. We can go ahead and write out the equation, seeing what's going to happen here. We have our lead-2 nitrate, and we're going to mix it with 2 equivalents of potassium iodide, and we're going to get a precipitate forming. And we'll get 2 equivalents of potassium nitrate. Running out of space here. All right, and of course, we won't expect to form a precipitate always. If we keep the concentration of lead and the concentration of iodide very minimal, we wouldn't expect to form a precipitate. And of course, that's going to vary substance to substance, and that's why we were given this KSP value. So whenever you see KSP, what should immediately pop into your mind is this expression, which governs the dissolution of this compound. And we know, or we were told, that this value here is 9.8 times 10 to the minus 9. So as long as we have lead concentrations and iodide concentrations low enough that we keep this value here lower than this value, then we wouldn't expect to see a precipitate. But when these values start ticking up, then that's when the precipitate will form. So the question becomes, are the values in this specific circumstance sufficient enough to cause the precipitation? And so to evaluate that, what we're going to need to do is we're going to need to find the concentration of lead and the concentration of iodide. Now I know we were given the concentration of lead and the concentration of iodide ions, but what we have to remember is that we are effectively performing a dilution here. In other words, the lead ion concentration started out as 0.10 molar, but it won't remain that way. We're taking 5 milliliters and diluting to a volume of 505 milliliters. So what we're going to have to do is we're going to have to find the new concentration. And so what is that? So again, we're going to use M1V1 is equal to M2V2. We have an initial molarity of 0.10 molar. Okay, but that was before the dilution. We added 5.00 milliliters. And we're going to solve for that new molarity given our total volume now is 505 milliliters. How did we find the total volume? Of course, we just added the 5 milliliters to the 500. And when you do this, you'll see that we're going to substantially dilute the lead ion concentration, and that makes sense given that we are taking so little of it and increasing the volume by so much. So the new lead ion concentration is 9.9 times 10 to the minus 4 molar, and that makes sense given we did about 100-fold dilution. Now we're going to look at the iodide concentration, the new iodide concentration that is, and see if we can find that. Again, we're going to use M1V1 equals M2V2, and this time we remember that we're starting with 0.150 molar iodide concentration, and we're starting out with an initial volume of 500 milliliters. We're going to be diluting it to some unknown new molarity, but our total volume is going to be the same as it was last time. Of course, the total volume of the solution is 505 milliliters. We'll see that the iodide concentration hardly changes at all. When we work this out, we get M2 is equal to 0.1485 molar. And I have 2 sig figs in the problem, but I can worry about rounding, of course, at the end of the problem. So now all we need to do is we need to calculate Q. Remember, Q takes the same form as K, so Q is going to equal the lead ion concentration times the iodide concentration squared, and we'll plug these values in that we just found for the lead ion and for the iodide ion, and we will check it out to see whether the precipitate will form. And when we work the math out, we find that Q is equal to 2.2 times 10 to the minus 5. Now that in and of itself tells you nothing, except when we compare Q to K. And we say that Q is 2.2 times 10 to the minus 5, and we remember that our KSP value is 9.8 times 10 to the minus 9. And so we see that Q is much, much larger than K, and so yes, the precipitate will form.